Previously on the Carbide Camp Knife series. Despite a few chatter-related hiccups during machining, we now have blades with bevels roughed in and all the other external features defined. The next step in the knife making process is to start manually finishing the blades, stopping just short of our final grit of sandpaper in preparation for heat treatment. Before we get into the really fun process of sanding, I want to explain why a sanding block is useful. When you're finishing a knife, you generally want your sandpaper to remain flat so that you don't start rounding over hard edges and letting different distinct faces blend into each other. This way, you can keep your grind line and any other features really crisp. While you could just wrap some sandpaper around a piece of bar stock or anything else flat, holding your sandpaper in place by hand for prolonged periods of time is going to be quite taxing. But the sandpaper also needs to be easily removable because you'll be replacing it quite often. So I've come to appreciate knife sanding blocks like these that give you 3 accessible faces that let you maximize the amount of usable sandpaper. This design is conceptually simple. Machine a rectangular block, cut a bunch of U-shaped channels in it. In fact, you could probably make this on a router table with a small bullnose end mill, but let's be real here, the only way I'm going to make a sanding block is with a CNC. I'm choosing to make mine out of HDPE because that's what I have on hand, but you could choose anything from aluminum to wood. Just make sure you don't use anything soft like pine because you don't want your corners to dent if you apply any pressure on those edges. The tougher the material, the better. My Fusion model is a block that I've extruded several cuts through and applied filleting as needed. Because I'm starting from a 1-inch block of HDPE, I'm going to run an adaptive roughing toolpath to blast open an area for my end mill to work. Having this short tool cut an inch deep would be a little risky. The rest of my toolpaths are mostly a combination of 3D pocketing and 3D contours. I do a little bit of containment in the geometry tab and heights tab, but for the most part I'm content to let Fusion apply whatever toolpaths it deems necessary to cut the features modeled. HDPE is so soft and easy to cut that whatever Fusion decides to do will probably be fine. I knocked this out on a coworker's Nomad since mine was busy beveling blades. You will need to flip it over and machine the bottom, but the alignment really isn't critical. All I care about is that there's enough room for a rubber band to be fully recessed in that channel. Also, to make a point that you really don't need complex toolpaths to make this sanding block, here's what something comparable would look like in Carbide Create. Assuming you have stock already planed down to the right thickness, just run a pocketing toolpath in the vertical channels, run a contour toolpath around the perimeter of your block, and pocket out the horizontal channels with a ball end mill installed in your CNC. You might have to round over a few edges with a file, but for a toolpath that took 2 minutes to come up with, that's not so bad. Getting back on track, once I was done, I used some 3/16" steel dowels which I'd purchased at the hardware store and cut to length, plus some rubber bands to hold my sandpaper in place. It would be better to use O-rings because you can get them in very specific lengths and strengths, but as an amateur making only a couple blades, I found this to be good enough. With this project, I planned on leaving 2 knives with the raw CNC finish and 2 that were sanded smooth. I bought a variety of aluminum oxide sandpaper up to 800 grit online and pre-cut a bunch of strips to a good size for my sanding block. You're going to go through this stuff pretty quick. I first loaded up my sanding block with 220 grit, but in hindsight something closer to 150 would probably have been more appropriate for the amount of material I had to remove. The technique for sanding blades is to pick a slightly diagonal direction and stick with it for a given grit. When all of your sanding marks are aligned in one direction, that means you've brought the entire surface down as flat as that grit can make it. This does take a while with the large macroscopic texture left by my CNC, and if you have any inclination to speed up the process with electricity, I highly recommend not using a deburring wheel. It's impossible to get crisp edges with one, and I only did this because I was impatient and I didn't have a vertical benchtop belt sander in my garage. I also wanted to blend out a little bit of the pitting near the back of my swedge because, as I mentioned in the previous video, turns at internal corners are bad, and in addition to the one at the plunge line, there was also one on the spine side of the blade when 3D contouring. So because of my shortcuts, the blade where I wanted to hide my machining marks ended up with softer grind lines. That's something I could overcome with time or experience or the right tools, and for me it's a good point to learn from. It'll change how I approach doing this in the future. Either I'll put in the time to do it right or just embrace the CNC finished look. To clean up the flats on my knife, I ended up resorting to my second-hand belt sander at 220 grit. I really don't trust the platen on this thing, but across such a large surface area it did good enough. From there I lightly finished the flats to 600 grit by hand. This is how my knives looked the night before heat treating. Despite some regrettable sanding shortcuts I took getting to this point, I was pretty happy with my progress so far. I started this project not sure if I can even make something remotely resembling a knife on the Nomad. Even though I'd done some extremely small-scale tests in this grade of steel before, I had no idea how my Nomad would handle hours and hours of continuous machining. Getting to this point was a huge relief, but the part I was most nervous about was still ahead of me: heat treatment. A crucial but delicate process where you need to bring a blade into a narrow temperature range before quenching. Missing your mark could leave you with either a knife that doesn't hold an edge or cracks outright. And given that I've never hardened steel before, the stakes are kinda high, but we're just gonna have to forge ahead and hope for the best.